Let's move on to the next question. So here we have to find the sum to infinity of a geometric progression with the first three terms, this, and this. So sum to infinity is equal to 1 over, what is the equation? Sorry, it is not 1 over, it is a over 1 minus r. Okay, so let's first find the value of a and the value of r. So here we have the first term is equal to 0.5. First term is obviously a. And what is the common ratio? We understand that to find the common ratio, we take what? The first term multiplied by r will give you the second term, which means r have to be 0.5 square. 0.5 square is 0.25. So the value of r is 0.25. Just replace back in the equation. A will be 0.5. 1 minus 0.25 should be what? Should be 2 over 3 as your sum to infinity. That is part 1 of the question. Now for part B, the first two terms in an arithmetic progression are 5 and this. So this is the first term, which is a. Second term, which is 9. Now again, we realize that when you have 5, 9, it is an AP, and the common difference will have to be the value of 4, plus 4. So D will be the value of 4. Okay. Now the last term in the progression is the only term which is more than 200. Okay. Find the sum of all the terms in this progression. So pretty easy. Let last term be equal to L. So we know the last term is equal to more than 200. So how do you find the nth term? For example, we know the nth term is given to you by the formula, which is a plus n minus 1 times d. Now nth term, when n equal to L, that should be a is 5. That should be L minus 1 times d should be 4. That is 5 minus 4 is 1 plus 4L. That is my last term. As you can see, my last term has to be what? 1 plus 4L more than 200. So 4L has to be more than 199. L has to be more than 49.75. So the last term has to be at least more than 49. The next integer after this number should be L should be 50. If that makes sense, right? Because term is always integer terms, right? We cannot take a term which is 49.75 term, if that makes sense. The next integer after this will be 50. So in total we have 50 terms. Now we have to find the sum of the first 50 terms. From the sum of all the terms, so we have to find the sum of the first 50 terms. So pretty easy again. We'll just use the formula we know already, which is half times the value of n, which is 50, times 2a. 2 times a is 2 times 5, which is 10, plus the value of n minus 1, n is 50c, minus 1 is 49, times d, d is the value of 4. Okay, so let's find out. So half times 50, this is simply 25 over here, and the value inside should be 10 plus 49 times 4, that should be 206. So times 25 should be 5150. Okay, that should be the sum of the first 50 terms of this progression. So the main idea here is we had to find the last term of this progression by using the formula that we know, or the given information. And then from that, we have to find the sum of all the terms. Now we know all the terms is 50 terms, sum of the first 50 terms by using the formula to find this. This is given to you again. You don't need to memorize the formula. We just have to replace and find that value at the end.